second session. And again, I want to start by apologizing for my mistake last week in not being able to tell the right time, but I am live today. If there are any questions from last week or as we go through, please post them in the chat room. I'll try to watch that. Or you can raise your hand and we will stop and answer questions. So I do want you to interact with me. And so please feel free to ask questions. So I'm really thankful that you decided to come back and join me. We understand a lot of people are now back in session, which is good news. But we're going to talk today about our second session, which is the task. Remember what I told you last week is we're using the National Council of Teachers of Mathematics, which has asked us to think about, actually this came out last year in March and then again in June, and it said when we went back to school in the fall, we had to be ready to really focus on those critical areas. So we needed to know what are those 4 or 5 critical areas. Kindergarten only has 2. What are those critical areas that we needed to focus on? And those are the big ideas of mathematics that must be addressed so that children do not have any unfinished learning. And then when we did that, we was able to determine what's the prior knowledge that students will need in order to access this new learning. Then it asked us to determine what students know through assessment practices using rich mathematical tasks instead of the typical pre-testing and post-testing that we have done. So that's what we're going to focus on today. What do those tasks look like? If I am my formative assessments, my summative assessments, what do they look like? And then, of course, what we're going to be doing is we're going to be addressing those 8 high leverage teaching practices of what is it that effective math teachers do. So as we go through this, you will notice in these 4 sessions that we are really addressing those teaching practices. So session 1, we talked about what the literature tells us about how do we plan the journey for our students. And so we will look a little bit at that because what we're going to do is we're going to talk about the tests that we do in those chunks of information or those learning progressions, as we call them. So session 1 was on the journey, the planning. Session 2 is on the task. Session 3 will be on facilitating that meaningful discussion, that whole idea of disciplinary literacy in our math class, and how do we facilitate pose questions that allows this to happen. And then in our 4th session, we're going to look at what is our evidence that students have learned? What does it look like, the learning? So explore tasks. So let's get started. And as we said last week, we all use the backward design. I identify the learning goal of my unit. Now, keep in mind that if a lot of our textbooks are done on topics, they are not done on a big idea. You do a topic and another topic and another topic, but children never get an opportunity to put the puzzle together. So what is the unit? What is the big idea that I'm trying to address? Then after we do that, we say, well, what is the evidence of understanding? How do we know what our students understand? What is the prior knowledge? Because they need access. And then what were those learning progressions? So that's what we did in our first session. So we went and I'm going to keep following this one on fractions because it's the same process we're using in all of our grade levels. But I'm using here, some of you might recognize it, Eureka Math, New York Engage, Match Fish Tank. They all have the same scope and sequence. All of the new digital material focuses on the big ideas. So big idea in grade 4 is fractions. Fractions on the number line. Remember and recall that I told you last week that this is a big idea. This is called a domain. Prior to 2010, that was called a standard. Now, this is why we get in so much trouble with quote standards-based grading, because prior to 2010, the international benchmarks, this was called a standard. Today, we call it a domain. Then under that domain, there are clusters of similar skills. So one of those is extent understanding of fractions, equivalence, and ordering. And then under that, there are fractions, standards, or skills. Those are depth of knowledge, 1 and 2, cognitive complexity, 1 and 2. They are not of higher complexity. You can either do it or you are approaching it. You have the skill or you're getting there. It is a skill. And then we have another cluster, and then we have one standard under it, which has several skills, by the way. And then we have a next cluster, understanding decimal notation, and then we have the standards underneath it. So it's domain, cluster, standard. That's the hierarchy or the structure of our standards. And knowing that is very critical for what we're trying to do. So in grade 4, let's look at what it says. It says they use models. They're able to recognize, generate, and compare equivalent fractions using these models. So what are some of the skills? Compare fractions with different numerators and denominators using visual models and reasoning. Factor pairs of whole numbers, know what a prime number is, know what a composite number is to 100. Add and subtract fractions and mixed numbers, and decompose and compose fractions. Those are skills. Those are the standards. And understand that denominators of 10 and 100 represents decimal notation. Now, remember, those are skills, but I have an ultimate goal. What is the goal? Why am I learning these skills? What's the purpose of them? And so that is the purpose. We're going back to the goal of the unit. And last week we showed you, I can understand, I can use my understanding of equivalent and decimal fractions to solve problems. The ultimate goal of learning the skills in mathematics is to solve problems. And so my unit is about decimal fractions, equivalent fractions. But why am I learning all of these skills? So that I can solve problems. So after we did that, here was the evidence of learning, and I'm using a borrowed from one of the schools that I'm working with. This was their simple evidence of learning. One question, but notice it's a very simple arithmetic question. But where the rigor comes in is the brain dump question students to talk about. So if you take a look in the literature about a good assessment task, it can be a very simple arithmetic task, which is what this is. However, I want to make sure that children understand this. And so that's why it said, ask those brain dump questions. What do they really know about this? How many squares are shaded? What decimal fraction does that represent? How can you represent using fractions and decimals? And so on. So you see those brain dump questions of allowing students to really dig deep into what they understand. That's what a good assessment should look like. Now, let's step back and let's think about, how do we assess mathematics? Notice the criteria for assessing math is there is some content. Secondly, can I use that content to problem solve? And thirdly, can I construct a viable argument of why my solution is correct? So in any assessment, it's not just about an answer, but it's also about, can you take that and use it to solve problems? And can you construct a viable argument and look at what others have done and critique them? That's the criteria for assessment of mathematics. So this is really digging in the brain dump questions dig into what is it they really understand about this picture. So if we go ahead, then that's my evidence. Now, then what we did was, okay, what is the prerequisite? Because now I have left third grade and I'm entering fourth grade, studying fractions. Do I have access to this new learning? Third grade, they identified and described equivalent fractions using the number line and visual models. So in third grade, if we look at what were the skills, they learned that the fractions were a part of a whole. They learned how to use the number line. They compared fractions by reasoning about. They compared fractions using visual models and number lines. And then they began talking about fraction equivalence. All of this is necessary to give them access to the grade 4. This goes back to Vygotsky's. Remember, there's 3 circles in Vygotsky. It's here, the middle circle, the inner circle. Here's what I know. And the outer circle is, here's where you want me to go. But in the middle, that middle circle, it said, here's what I can do with support. And that's what we want to know. What do they already know? Here's where I want them to be at the end of grade 4. What with support can I do to move that learning forward? And remember, that's what formative assessment is all about, moving learning forward. So I know the prior knowledge. So this was a task the teachers had selected to do, to see what do they already know. Notice Eva and Sean each bought a small cheese pizza. Eva cut hers into 6 pieces, slices, and ate 2. Sean cut his, same size, ate 3 and ate 1. Eva said she ate more. Sean said, no, we ate the same. Who is correct? Explain how you know. Notice it is in context, a good problem in context. We want to make sure the names are correct. The children understand the names. We want to make sure the context is good. And then the most important part of this is down here, where I have to construct that argument of who is correct and how I know it is correct. Now, this is an authentic type of problem, because when you think of what does it mean to do authentic real world problems, sometimes they're very simple. They're just the things that you and I encounter every day. So we buy a small cheese pizza. We cut it into 6 slices, 3 slices. I eat 1, you eat 2. Who ate more? How do we know? So again, getting that conversation, that communication going, which is so critical in mathematics. So now that was what I had to do was, let's plan the trip. Let's map out the journey. And that's where those learning progressions came in. And so when we looked at the evidence of understanding that we have, here are the big chunks that I need to get there. Now, when I look at this, again, remember, if I look at any of the literature on inclusion, teaching math to language learners, it talks about making sure that I chunk I have a goal. This is what I want my students to be able to do. This is where I think they're coming from, but I'm going to pre-assess and make sure they have access to this trip. Do they have access to this highway? And then we begin the journey. And that's where we're at today. Let's talk about what are the tasks that I do on this journey to achieve this goal. So the first thing I'm going to do is, because we have lots and lots of standards, and they're not a checklist. We never want them to be a checklist. However, some of those standards are priority, and some are supporting, and some are just additional. So on the Focus 2021, on the Focus 2021, I notice here, grade 4, down under Focus 2021, the Student Achievement Network NCTM and Achieve.org have gone in and looked at the standards and said, which are the skills that are priority, which of the skills can I reduce, and which of the skills can be eliminated this year, they're not necessary. Because remember, the whole idea was declutter your math curriculum. So in the decluttering, I go here to see, is there anything that I can leave out of the 4th grade unit on fractions? And what I notice is time spent on instruction and practice should not be reduced. Now, there are other areas here that I'm going to see where it says reduce it. And in others, it says eliminate it. So I have not only the big ideas, I now have down to the skill level that I can really plan a well-posed unit on fractions that gets to the big idea and the skills that are necessary. So as we move on here, there it is. Now, I already said that. So now I'm back here and I'm ready. I've done my pre-assessment. I'm ready to start this unit. And my goal is I can compare using visual models, 2 fractions, different numerators, different denominators, using less than, greater than, or equal to by comparing to a benchmark fraction. So that's the goal of this unit. Now, remember, I said last week, I like to call these lessons, but a lesson is not one class period. A lesson, I can be doing several activities, but I have in mind the goal that I'm trying to reach. So I'm going to do some problems. I'm going to do some exercises, some different activities in order that children can achieve this target so we can move it forward to the next target. So there's where we're at, using rich mathematical tasks. What is a rich mathematical task instead of the typical pre-testing, post-testing that we do? What I'm going to do is I've identified my learning goal. There it is. Then I look for a meaningful task. Now remember, I'm just starting this unit, and I don't begin by teaching them the skills and then giving them a problem. In every study that is out there, it says, give them a meaningful task to begin with to see what do they know about this target. What is it they already know about comparing fractions using visual models? What do they know about less? I'm going to come up with a task that is in good context that allows them to complete the task, because what I want to know is, what do they already know about this topic? What do they already know? I want to get a good vision of that, so then I can plan the skills that we need to work on. Then we have to try the task ourselves. We have to have an idea of what we think children will do. We create questions and answers to support students who are struggling and to enrich those who move forward. Now, this is why we don't need a lot of these tasks. We only need a few. A few good tasks go a long way in a math class, much better than giving me 10 to just write a repetitive answer. So, in the principles to action, here are the high leverage teaching and learning goals. And I'm going to go to the next slide because I want you to look at it. It says an effective teacher always establishes a goal to focus on learning. So I've focused a goal to focus the unit, but then I have focused a goal of this is a chunk of information, a progression that they need to know. So I have a learning target for that. Then it says, once you have that target, I'm going to implement tasks that promote reasoning and problem solving because this is how I build conceptual understanding this is how I build procedural fluency. When I understand why it works, the how, the fluency happens. So understanding why it works is what we work on to build that fluency. Now remember, fluency in mathematics is defined as being efficient, being accurate, and having flexibility with numbers. So we're in grade 4, but all of my primary school math is about building that flexibility of taking apart, putting together numbers, addition and subtraction, composing and decomposing. So primary school, that's its purpose, so that in 3rd, 4th, and 5th grade, I can take what I have learned and I can build that deeper understanding of multiplication, division, and fractions, which is what 3rd, 4th, and 5th grade is all about. Now, by the time I get to middle school is all about proportional reasoning. But the foundation is laid for all of mathematics in elementary school. Primary teachers lay the foundation for all of math, the building, the composing, the decomposing of numbers, which is essential to become fluent in mathematics. And then, of course, we're going to be talking later, next session, about how do we facilitate that meaningful discussion. But now I have my goal, and I'm going to implement a task. If you take a look, this describes what students will be doing in the classroom. Just like my content standards are not a checklist, I never ever want to see these as a checklist. It never works. It doesn't work. I don't want to ever hear anybody say to me, we're working on math practice 3 today, or we're teaching that. You cannot teach the practices. It's what the students are doing. How do they acquire this? Through good opportunities for problem solving. But more importantly, even prior to our new standards in 2010, we had what was called the processes of math, representations, connections, as communication. I can't think of the 3rd one or 4th one right now. But nevertheless, notice how these are bundled into 4 categories. The first one is that overarching habits of mind. Children can make sense of problems, they can persevere, and they attend to precision, accuracy in vocabulary, accuracy in computation. They can reason and explain. They can change words to numbers, numbers to words, and they can construct a viable argument and critique the reasoning of others. They can model with mathematics. Remember modeling with mathematics. Remember what mathematicians do. The definition of mathematics is it's a way of describing a phenomenon. It tells a story. So mathematicians encounter a problem, a situation, a phenomenon. What do? They look for patterns. When they look for patterns, what do? They make generalizations. And then they construct a model to solve the problem. A number line is a model. What do you call when you take apart number bonds are models. Bar models, part, whole are models. A graph is a model. A number sentence is a model. An equation is a model. So I model with mathematics. I create models to solve the problem. And then lastly, I see structure and generalization. This is the beauty of mathematics. All of the properties of mathematics are learned by grade 5, or should be. because there's nothing new in middle school or high school when it properties. We just choose different numbers. And so once I learn to reason in mathematics, once I understand the structure of mathematics, then what does middle school do? They give breadth and depth to what the elementary teacher has done. What is high school about? High school is about those different pathways that children can enter. So the National Science Foundation in the US says all of the mathematics I need to know, I've learned by the end of grade 5. It's taught in elementary. Middle school gives breadth and depth. High school is about pathways. That's this generalization, the structure of how the content is laid out. So if we go to PISA, the Performance in Student Achievement from the Office of Economic Cooperation and Development, the PISA is administered to 15-year-olds in countries around the world. I think 86, 87 countries participate in the PISA. Or if you go to the PARC or the Smarter Balance in the US, and you can look at other countries as well, but if you look at that assessment, their large-scale assessments, and in the US it's from 3rd grade through high school, there are 4 criteria. They are the same around the world. There is that content I talked about. That's your arithmetic. Then there is the ability to problem solve. Then the ability to construct a viable argument and critique others' reasoning. And then there is modeling and data analysis, or can I apply it to an authentic situation? Now, take a look at this, because this is literacy in mathematics. This is why I don't want to see the practices as being a checklist. Why? Because I have my concepts and procedures. My content is about that structure, that repeated reasoning that I do, which also falls down here, by the way, under communicating reasoning. It's about problem solving. It's about communicating my reasoning, and it's about modeling and data analysis. So when I look at all of this, and I think of literacy in mathematics, what does it mean? It's about reading and writing and speaking and listening, creative thinking, inquiry. All of that is a part of literacy. It all occurs down here. This is just arithmetic up here of giving a procedure. So with that said, math is taught through inquiry. It's the only way children will build their understanding. We give them a question. We ask questions. Children investigate those questions or create their own, hopefully. And then from that, you create or construct new knowledge. Then we talk about it, we discuss it. And when we look next week at the importance of discussions in the classroom, because this is when children learn the mathematics, through the creation and through the discussion. This is when those experiences begin to stick. And this is when that fluency becomes evident. Then we reflect on what we've learned, and then we repeat the cycle. So inquiry is a critical part of mathematics teaching. We begin with a good question, and often it's a good problem. We allow children to investigate it, allow them to construct new knowledge from this. Then we bring them back together and we share. How did you solve it? What was your thinking? How did you solve it? What's your thinking? How is your way similar to someone else's? How is it different? And then we step back and we reflect on what we've learned. And then the cycle begins all over again. That's how mathematics is taught. That's how mathematics is learned. So with that said, let's take a look. Math class should be problem-based learning. There's just no getting around it. There's nothing we can say any different if we just understood what does it mean to have a problem-based class. It's when students are placed in the active role of engaging in the process of problem solving. They're confronted with a problem. How do they solve it? How do they approach it? And notice it says it must mirror what we would do in the real world. In the real world, people don't tell me how to solve problems. Often in the real world, I've got to figure out what is the problem. I'm given a situation and I have to decide the problem. So problem-based learning is the way to go. So here is the definition of a problem. Any task or activity for which you have no prescribed or memorized rules or methods, nor is there a perception that there is a correct solution. In other words, it's doing what to do, knowing what to do when you don't know what to do. Let me say that again. When you confront a problem, it's knowing what to do when you don't know what to do. Think about a problem that you have encountered, a real authentic problem, and stop and think about how did you approach that problem? I share that since I've been home during the pandemic and living alone out in the country, no neighbor, no friends nearby, nothing open. I've encountered a number of problems. My first week home, I encountered a problem with my refrigerator. And the question was, what's wrong with my refrigerator? Why isn't it working right? Can't call anyone. There's no repairman going to come. He's not going to work with me. So what do I do? I have to figure out what's wrong with my refrigerator. So where do I access that information? Well, thank God for Google. I Googled what I saw and it came up. And then now I knew what the problem was, but now how am I going to solve it? I'm not a refrigerator person, a refrigerator repair person. I certainly don't know anything about that, but thankfully I saw how to repair my refrigerator with a YouTube video. What I'm saying is, in the real world, when we encounter a problem, it's knowing what to do when we don't know what to do. It's really knowing how to learn. This is what this is all about. How do we help our students to know what learning is all about? We define learning as active process, it's engaging, and we go through all of that. But what does it look like with our students? Because when you give children a very simple problem in context, how do they solve it? How do they approach it? This is what problem solving is all about. Now, that brings us up to problem solving is engaging in a task for which a solution method is not known in advance. Now, I want you to think how many times in your life when you were doing math did people tell you how to think? I see this far too much in middle and high school. Use a quadratic formula to solve this problem. Use the ratios to solve this problem. You just said to the child, I'm doing the thinking for you. Now, is it necessary? Absolutely. If we're doing exercises, we do some of that. But if I'm really engaging in problem solving, I don't tell people how to think. I want to know, how do you think? So this engaging in a task for which the solution method is not known in advance. So every time we give these hints, we have just said and limited the child's capability to think. What is learning? We need to help our children to learn how to learn. And I think that's the thing that's going to come out of the pandemic more than anything is we've had to focus on the learning. What does it mean to learn? What does it look like? In my parent presentations, I say to parents, don't be teaching your children, don't be putting them on, now I get in trouble, but any of the programs that are out there, I won't mention any, and have them practice. It's not going to get them very far. There are so many things that you can do to help them to become good learners, and the mathematics will come, but we can't be telling them how to think or just to practice a bunch of arithmetic problems and think that we're going to address this problem. So there are problems and there are exercises. Most of our instructional materials, according to the American Institute of Research, according to achieve.org, are not problems, they are exercises. We need both. No one is saying that we're going to eliminate the exercises, but I'm going to begin my chunk, each of those chunks, with a problem to see what they already know, what can they already do, and then I will come back and I will do some exercises to build those skills. But I'm not going to be teaching skills, practice, and then do a problem. There is an article I have on one of the live minders. It's called Turning Teaching Upside Down. And one of my favorite books is Turning Learning Right Side Up. Think about that. Turning learning right side up. Let's see what it is that children know. What are the skills that we need to build versus let's do all of these skills, let's practice, and oh, maybe we'll do some problem solving. No, let's begin with problem solving, see what skills they have, what skills do we need to work on, and then we can do our exercises. So what is a problem? We already defined it. What is an exercise? A set of number sentences intended for practice in the development of a skill. So let's take a look. If you want to know if you're involved in, are you engaged in exercising or problem solving, I put up this sheet. I'm not going to read all of this to you, but you have it. If you're only looking for one answer and you give them all the data, it's an exercise. If it's a well-defined situation and you give them the problem, it is an exercise. If it is something that you have done before and now we're just practicing, it is an exercise. There's usually one approach which gets to the answer. And usually it's a very familiar situation. It involves one subject and in many cases, one topic. So today we're doing addition and subtraction of fractions. Well, the child already knows what you're going to be doing because that is the goal. We're going to add and subtract fractions. We've already told them that. Well, what if I give them a problem that may not require that? Do they know what to do? Communication skills are not essential. Now, here again, a lot of times we give them an exercise and we say, explain your thinking. So you know what they do? They come back and they tell us how they did it, not why they did it. They explain how they did it. And some kids have lots of examples of this, is because, well, I've already showed you with numbers, why am I going to write it? And so they just leave that blank. But explain your thinking, get them to understand that that means justify your thinking. Why is your thinking correct? Not how did you do it, but why did you do what you did? And of course, over here, that is the complete opposite. So let's take a look. Naturally, these are exercises. Even though I say, how can you tell? It's still an exercise. Even though it's a word problem, it's still an exercise. So if we think about that, we do both. And absolutely, they both are essential. But this doesn't come first. First comes, how would you solve this problem? What are the skills that you have? Well, yeah, it'd be nice if I put up the whole problem, wouldn't it? Okay, so this too comes from one of our online curricula, actually out of Georgia, and it's a good exercise. It's a lot of words, but it's good exercise. And nothing wrong with it, but it's not where I'm going to start. So we're talking about fractions. I want you to take a look. This is the one that the teachers came up with to start this unit. So Miguel is going to plan an obstacle course for field day. Notice how I would make sure my students understood the language, because part of what we do, remember mathematics. Mathematics is a language in itself. Every child in your classroom is a language learner, because mathematics is a technical language. Then there are other things that we want to make sure. Do these students understand what an obstacle course is? Do they understand what a field day? So we build that vocabulary absolutely up front. At the end of every sixth, there is a tire. At the end of every third of the course, there is a cone. At the end of every half of the course, there is a hurdle. Explain to Miguel at which locations people will need to go through more than one obstacle. Now, here's where I would not give this question at first. I would do this story. That goes back to what it says in our literature about teaching math, the 3 reads. The first read is we're going to read the problem. And this is a good habit to establish with kids. What's the story about? Can you draw me a picture of this story? Do you have a visual of this story? Oh, there's going to be an obstacle course. And I'm going to put a tire every 1/6 of the way. And then I'm going to put a cone every 1/3 of the way. At the end of every half of the course, I have a hurdle. Do I have a picture of this? And the second read then we put in every 1/6, every 1/3, every half. We put in the numbers. First read is a story. What's the story about? Second read is, what are the numbers? Put in the numbers. And then the third read is, all right, what's the problem? What could be the question here? So Miguel has at which locations people will need to go through more than one obstacle. Notice it's critical mathematics. It gets at equivalent fractions. The other thing is that it gets at communication, the ability to communicate, and it also gets at the ability to problem solve. As simple as it is, I've got to come up with a strategy of how am I going to approach this problem. This goes back to Pauly's book on problem solving. Remember, he said, when you read a problem, when you confront a problem, first thing to do is visualize it, draw a picture. Either put it on paper, or do I have a picture in my mind of what it says? Then we put in the numbers. So that 3 reads is critical for building the literacy we need in mathematics to build the language. Remember, mathematics is a language. And in that language, we often, prepositions are a problem in mathematics because of the way we use them. It changes, particularly in middle school, it changes how I solve a problem. Syntax, symbols, equations, and we put words and numbers together. A symbol is like a sight word in mathematics. Do they recognize those symbols? So building that through problem solving doesn't do any good to teach the vocabulary if I've not encountered the vocabulary. So Here's an example from the 5th grade of the same school. Willie earns $11 a week mowing lawns. He wants to earn enough money to buy a video game that costs $110. Find the number of weeks it will take Willis to earn, I can't read, Willis to earn enough money to buy the video game. This comes right out of their text. It was not a problem solving. It was a word problem. It was an exercise. So their question was, how can I make this much more engaging? So here's what they did. Okay, if I can change my screen. And it's being stubborn. There we go. So, and this is pretty good. There are a couple of things that I would like to have seen different, but I like what they did. Willis earns $10 to $25 a week mowing lawns. He wants to earn enough money to buy a video game that costs him $150. Now think about it. I want to buy something. I can make this much money, but it says give a minimum of 3 ways in which you can earn the money, purchase a game system. Which way would be the most efficient to earn the money? Explain. I'm getting that communication piece. I'm getting in the problem solving. The other thing that I think that one of the teachers tried that I liked was that Willie could mow Mrs. So-and-so's lawn and Mr. So-and-so's lawn. He had 3 lawns he could mow and what they paid. Now, which of the lawns would you mow to get the money? And I thought that was even much more of problem solving, but this is good. I have to make a decision about, okay, which one of these, how will I mow these lawns to get this much money? And why is it efficient? Now here again, efficiency is a personal thing. So the answer might vary. I was sharing the other day, we were looking at some student work at one of our national assessments. And one of the questions had to do with Louis and Jose were eating pizza. And he ate so much of the pizza and Jose ate so much of the pizza. And who ate more pizza and how do you know? And one little guy, this is like 3rd grade, one little guy said, well, Jose ate the most pizza. I know Jose and he always eats the most pizza. Well, that was his answer. He knew, he was a friend of Jose, and no matter what you did, Jose always ate the most pizza. So there was no reason to work out the math. And so you have to step back and think about, okay, now they're making a connection to the story. And then you can work on the skills, but it's that idea of helping kids to see the beauty of mathematics, that mathematics is in everything that we do. And then, well, I'm not going to have time for this, but let's go to the 1st grade. But 1st grade, we're working with numbers. Emma chose 2 numbers and added them. Mike chose 2 numbers and subtracted them. They both ended with the same amount. What numbers could Emma and Mike have used? Much more engaging. It says, show your thinking using pictures, numbers, and/or words. So the beauty of this is, as we're going to see in the next session, is when I have all these different ways of thinking, I have some great mathematical discussions of how different children approached and solved the problem. And this is when mathematics is learned. It comes through those good discussions, through those investigations of trying to figure something out. And then let's do one here and from 3rd grade. 4 bags contain a large number, 1s, 3s, 5s, and 7s. Pick any numbers from the bag, so the total is 30. And some students will recognize right away, well, I can't make 37 because those are all odd numbers. So what can we add to that? What numbers could I make from here? Do those numbers have anything in common? Could you make 37 if I change the amounts in the bag? How could I make 37? What do you notice about the numbers in the bag? The point we're trying to make is one good question goes a long way. We don't need a lot of these problems. We need a few because we do have to practice. We do need the exercises. But for every one of those chunks, those learning progressions, I need a problem to get me started, to see what they already know. And then I need a problem to see how do I move the learning forward. We're going to practice those skills, but then are they ready to move to the next stone in the river? Are they able to move forward? But even if they're not, the way the progressions are laid out is, and this goes back to Vygotsky, I can scaffold the learning of the next progression so that all children have access. This is what it means by decluttering our curriculum. Jack has lots of shells, more than 40, less than 60. Counts by twos, he has one left over. Counts by five, he has none left over. The number of shells is more than half of 100. How many shells? Show your thinking and your reasoning. Getting that thinking going, allowing students to construct their understanding is what makes a difference. So, when students do computation, their thinking should be high level, critical thinking, including the same math that you and I use when we are engaging in problem solving in our daily lives. I want to take some time for some questions and comments. So if you wouldn't mind, I know there's few of us today because some people had to teach, but if you would turn on your cameras or your mics and talk to me for a minute, I would appreciate that. Any questions? I don't see any in the chat room. Comments? Anyone? Questions or comments? We have a few minutes. Anyone have any questions or comments? Well, let me remind you of what it says here. Not all tasks are equal. What is learned in the math class is going to depend on the kind of task you gave your students to do. Student learning is greatest where the tasks encourage high-level student thinking and reasoning, and least in classrooms where the tasks are very procedural in nature. So we've got to move away from teaching so much arithmetic and let's teach mathematics. The difference between arithmetic and mathematics, arithmetic is knowing the basic procedures of addition, subtraction, multiplication, and division. And it doesn't matter if I'm in elementary, if I'm in middle, I'm in high school. When I am adding, subtracting, multiplying, and dividing, doing those procedures, it is arithmetic. What is mathematics? It's a way of describing a phenomena. Mathematics tells a story. I should be able to look at an equation, a number sentence, a bar model, a number bond, and I should be able to tell you the story it represents. It's a model, it represents a phenomena, a story. And so the more we do of things like that, the greater will be the understanding of mathematics. And this is where procedural fluency is built, not through memorization, but it's through actual engagement. So if you stop and you think about it, when we were asked to declutter our curriculum, they were really asking us, focus on the learning. What is learning all about? Help our students to learn how to learn. That's the critical part of what we do. We have a few critical areas. In elementary school, the most we have are 4. That is our focus for the year. Declutter, build problem-solving skills, and the kinds of tasks. Now, does anyone have any questions? Be nice. A comment. You're allowed to comment.
Hi. Oh,
hi, thank you.
This is Ileana. We're in a room full. Sorry, I think there's a bit of echo. One moment. Okay, here we go again. Sorry, we've got two computers going on in the room. We're a group of 3 teachers here. We've got grade 4 and grade 1, and we are looking at finding the balance between the problem solving and providing those opportunities for students to grapple with their current understanding and be stretched. At what point do you have conversations where you also show some explicit strategies that will help them be able to problem solve with greater, efficiency and fluency? Is there a specific part in the inquiry cycle? Oh, sorry, you're on mute. Oh, sorry,
Myself. Okay, now
your mic is on mute, I think, or maybe mine is, maybe ours.
Okay, I'm muted now. Can you hear me? Okay, yeah, I said that's a very good question. So stop and think about it this way. Once you have that unit planned, you know the goal of the unit, correct? You know where you're going and you have those progressions, you know those chunks you're going to do. So I'm going to begin each chunk with a very simple problem that I know that my kids it's not going to be a challenge to them, just to see what their thinking is about this particular topic. All right. And I want to make sure that it has in it some problem solving, because it's something that they can relate to. And also that I'm going to ask them for some communication explanation. All right. Now, I am going to work on that. So whenever students solve it, we will be sharing out, and I think we'll get to that more next time. We'll be sharing out how did different groups do it. But we're going to talk about how do you sequence that. Now is the time then to talk about those exemplars of those good practices of problem solving. You build it in then. You don't want to do the strategies and then say, okay, let's practice those, but we're going to build them in as we go. I'll share a little story with you. I was working with a group of 7 fourth grade teachers, and there was 4 ladies and 1 man, and he did not want to do this. He said that it didn't work. He knew that it didn't work, but the ladies convinced him that it would work. So they said, let's begin this unit with a problem. And so they came up with a really good problem. And they said, what are you going to be teaching? And he said, the 7 strategies of addition and subtraction. And of course, they were always picking on him and teasing him. And they all went, woo, 7. We didn't know there were 7. And so it was kind of fun. But anyway, he said, okay. So the next day in the classroom, he gave this problem. And they worked in groups of 2. Those students came up with 6 of the 7 ways that he was going to teach. So when they were going over this, they came up with 6 of the 7 ways. And he was brilliant, because then he said, oh, I wonder if this would work. And he got in his 7th strategy. So then that night, what he said to them was, he gave them another problem. He said, I want you all to try it. And he picked out different people to try. You try so-and-so's method, so-and-so's method. Brilliant, because that's where kids learn. And so you can get those strategies in. If you take a look at what your students do, build on that. That's what this book called Turning Learning Right Side Up is about. It says maybe the student should be the teacher and the teacher the learner. Think about it. Students can be the teacher and the teacher the learner. So turning learning right side up. So take those strategies that students do, build your lessons on that.
Thank you.
Okay. Other questions? Comments? Well, I think our time is about up. Well, okay, if you have questions, by the way, you will get the PowerPoint. My email is there, and I do answer questions. So if there are questions that come up as you're working with your grade level teams, please don't hesitate. Just send me an email, and I'll happily answer those questions, or bring them next time when we're going to talk about how do we facilitate meaningful discussions in our classroom, which is where children learn the mathematics. Okay. Thank you.
Thank you, Irma, so much for your time today. We're very much looking forward to next week's session. We will be circulating this recording to everyone, so you can either rewatch it or share with your colleagues if they were unable to make today. Thank you once again, Irma, for an amazing session.
Okay, and I will send you the PowerPoint so they have that as well. Thank you.
Thank you.